Hello, everyone. This video, we'll talk about correlation versus causation. So, what are these two terms? What do they mean? Well, correlation. Um, this is this happens between two events or two happenings, X and Y. Events is the term we generally use, and we'll talk more about events later. Correlation between two events occurs when there's an observed mutual relationship between the two events, or sort of between them. Okay, so that's the idea of correlation. It's that they sort of are happening at the same time. Sometimes they're not happening at the same time. So there's some technical ways to gauge when there's a correlation, but it's just saying that there's some relationship between one happening and the other. Um, Causation is something where, one event takes the blame. Okay, so this is when one event causes the other. All right, and now there's some notation for this that's in the book, and let's review it. So uh, if you have two events, you can write this. This means that X and Y are correlated. Cor so, um, and as we'll see, this is a very different thing than X being X causing Y, but oftentimes when X causes Y, uh, you will see a correlation, but not always actually, depending on your study. So this would be X causes Y. Of course, you can go the other way. This double arrow, this means Y causes X. And the point is that if you see a correlation, it may not be the case that you have either of these situations. So you could have that this is occurring, but neither causes the other. And we'll look at some examples of that in a moment. What could happen instead? Why would you have a correlation instead? Well, there are sort of three main reasons that I would point to, two of which are kind of discussed in the book. One is that you have this external cause, this third event that's happening that's causing X and Y, but that X and Y are sort of not causing each other. So here you'd have some extra cause C causes both an X and Y. So you're seeing them happen at the same time because there's some other cause for both of them. On the other hand, you could have even a more remote kind of relationship, but still a correlation where you have two different causes that are themselves correlated, um, one causing X and the other causing Y. And because there's a correlation between C1 and C2, um, you're seeing a correlation between X and Y. So this is a case where you get this extra correlation where there's not causality. So, and that's sort of the thing to remember. And it really is confused all the time in the media, is that you'll see studies come up and they'll say this is causing this or this particular, and what they're taking is some study that establishes a correlation, but is not establishing causation. And that's a very tricky thing because uh, you can get rid of X or Y in a correlation, and that may not get rid of the other one because it's not the cause. So, so this is something to be very aware of. Um, there's some there's a really nice example in the text that discusses, I think, actually, how difficult it is to really even establish correlation. So establishing causation is very difficult, and that's generally true. There's usually many, many studies that go into establishing a causation scenario. But even establishing a correlation can be delicate. And so there is an example in the book, and I'll briefly uh, just mention it about a National Institute of Health study on coffee consumption. And I have my coffee right here. So I would like to discuss that study. So that study, um, it said that I mean, the claim was essentially that coffee is correlated with longer lifespan. And what they did is they watched um, older individuals, and they basically looked at their lifestyle patterns, and then they just determined, who lived and who died over a 20-year period. Um, and they found that amongst the coffee drinkers, uh, they saw in men a 19% death rate, in women a 15% death rate over the study. And then the non-coffee drinkers, um, they found a 13% death rate and a 16%, or sorry, 10% death rate. So now I said they found that coffee drinkers um, had a better chance of living longer than non-coffee drinkers. And when you look at these numbers, you see sort of the opposite type of correlation. You're seeing that if you drink coffee, then you actually have a higher chance of dying earlier. So when you look at this, you're seeing the opposite kind of correlation. And then what they realized in this study is that there are other correlations occurring where they do know something about the causation. So if you're a coffee drinker, you're also very likely to be a smoker. I mean, in other words, many smokers have a much higher correlation to drinking coffee than non-smokers. Same with alcohol abuse, is that high alcohol consumers often drink a lot of coffee. So there's this positive correlation with drinking coffee and other things that are known to cause mortality, or at least to lead to higher mortality rates. Um, so within that, once they adjusted for this, they found that so after adjusting for other factors, they found that in these all of these other groups, the groups that are high risk for these other um, lifestyle patterns, that men had a 10% improvement in odds of or in lifespan survival, and women were 13%. So it's actually opposite correlation. So I think I think in the book they're trying to talk about causation, how this is when you look at correlation, you don't establish causation. And I don't think this study established any kind of causation with coffee drinking at all. What they did try to establish, I think, was some sort of correlation. So I think coffee being the cause of a longer lifespan is definitely was not shown in this study. It's an observational study. But I think what it really illustrates, though, is that when you're looking at data, even establishing a correlation can be a very tricky proposition. You have to take into account many other potential causes and other correlations to see and isolate what's going on. That said, let's look at a couple of these scenarios and just see what might be other factors. So we gave some general notation. Recall we had X is correlated to Y. So let's say you have a correlation. Um, well, you could think, let's take an example of, say, a virus and a fever. So like a cold virus. That kind of implication, well, not always, but can be there. So this type of causation uh, would lead to a correlation. That if you have a cold, then you get a fever. That's something that's typical. On the other hand, you may have a couple of symptoms like sneezing and a fever, and you can have a fever without having any kind of sinus issues, and you can have sinus issues without having any kind of fever. However, there could be a cold going around that causes both of these things. So you could have some kind of cold virus that's causing both of these symptoms. And so this would be a situation where, okay, you see a correlation between sneezing people and people with a fever. It's not a 100% correlation, but you see some correlation. And that's because there's some common cause um, happening. So this is this sort of C implies X and Y. This is an example of that. On the other hand, you could also say, well, okay, I have some people that are actually sort of coughing uh, for weeks, and and then I also have people that have a fever or had a fever at some point. And well, you could say there's a cold virus that causes both of these, but in fact, what's causing the coughing for weeks is some kind of sinus infection that resulted uh, from a cold virus or is correlated with a cold virus. And these are really the causes of the two symptoms that you're seeing. And so this is one of these cases where you have two different correlated causes. In this case, maybe an implied or a caused, there's a causal relationship between C1, C2 and C1, but they are the causes of these correlated events of having a fever and coughing for weeks. So these are just some examples of how you would, I mean, very simple examples of how you might see correlation. Um, but in these cases down here, where you have the cold virus involved and um, some symptoms, you don't have a causation. So coughing for weeks may have no implication of will not cause the fever, and the fever may not cause the coughing for weeks in these cases. Okay,